In the vast expanses of the universe, a mystery lurks, unseen yet omnipresent: dark matter. Imagine a cosmic enigma that eludes our sight and touch, yet exerts a gravitational pull so strong that it shapes the very structure of the universe. This is the elusive and enigmatic substance we call dark matter. Though it does not interact with light or any other form of electromagnetic radiation, its existence is inferred from the way it influences galaxies and galaxy clusters. It's like a phantom, exerting its will without revealing itself. Now you might ask, if we can't see it or feel it, how do we know it's there? The answer lies in the curious way galaxies spin. You see, galaxies spin so fast that, according to the laws of physics, they should tear themselves apart, but they don't. Some unseen force, is holding them together. And it's not just in galaxies where we find this mystery force. Its presence is felt on a much larger scale. It's the invisible scaffolding that holds the universe together, the unseen glue that binds galaxies into clusters and clusters into superclusters. Scientists estimate that dark matter makes up about 27% of the universe. To put it in perspective, everything we can see, the stars, galaxies, planets, you, me, all of this accounts for just 5%. The rest of the universe is made up of dark energy and, you guessed it, dark matter. But why is it called dark matter? It's not because it's dark in color. Rather, it's dark because it does not interact with light. It neither emits nor absorbs light or any other electromagnetic radiation, and so it remains dark, invisible to our eyes and our instruments. Despite its elusive nature, the concept of dark matter is now a cornerstone in our understanding of the universe. It's one of the biggest mysteries in cosmology, a riddle that scientists across the globe are striving to solve. Unseen, unfelt, yet undeniably there. Dark matter, the phantom of the cosmos. Our story begins in the early 20th century with a curious Swiss astronomer named Fritz Zwicky. Zwicky, a man who was as eccentric as he was brilliant, made a startling observation about the Coma Galaxy cluster. He found that the galaxies within this cluster were moving far too quickly to be explained by the visible matter alone. It was as if they were dancing to a tune that couldn't be heard, pulled by an unseen force. Zwicky proposed an audacious theory. There must be some invisible matter, some dunkel materie or dark matter as he called it, that was exerting gravitational pull on these galaxies. This invisible matter was what was keeping these galaxies from flying apart. But Zwicky's theory was not widely accepted. His ideas were too radical, too outlandish for the scientific community of his time. It was only decades later, in the late 20th century, that another astronomer, a woman named Vera Rubin, would find more evidence supporting Zwicky's dark matter theory. Rubin, while observing the rotation of galaxies, discovered something unusual. The stars at the edges of galaxies were moving at the same speed as those near the center, defying the laws of physics as we know them. This could only be explained if there was some invisible matter, some dark matter, exerting its gravitational pull. Rubin's work was a turning point, a moment of revelation. It gave credence to Zwicky's once-dismissed theory and brought the concept of dark matter into the mainstream scientific discourse. It was a discovery that opened up a new frontier in our understanding of the universe, one that we are still exploring today. So, the seeds of mystery were planted, growing into an enigma that scientists are still trying to unravel today. Over the years, scientists have devised ingenious experiments in an attempt to detect dark matter. One such experiment is the use of underground laboratories. These labs, often nestled deep in old mines or beneath mountains, provide a shield against cosmic rays that could interfere with the delicate detection of dark matter. Here, scientists aim to catch dark matter particles as they pass through the Earth, interacting weakly with regular matter. One of the most famous of these underground laboratories is the Large Underground Xenon Experiment, or LUX, buried a mile underground in the Black Hills of South Dakota. LUX uses 1/3 of a ton of supercooled liquid xenon, hoping to detect the tiny flashes of light that would occur if a dark matter particle were to collide with a xenon atom. Another approach to detecting dark matter is through the use of supersensitive detectors. These detectors, like the Cryogenic Dark Matter Search Experiment, or CDMS, are designed to pick up the faintest of signals, the smallest of whispers, that might hint at the existence of dark matter. The CDMS experiment, located in a former iron mine in Minnesota, uses germanium and silicon detectors cooled to near absolute zero to look for signs of dark matter particles. Yet another experiment is happening in space, aboard the International Space Station. The Alpha Magnetic Spectrometer, or AMS, is looking for signs of dark matter and cosmic rays, high-energy particles that travel through space. If dark matter particles annihilate each other, they might produce positrons, a type of antimatter particle, which the AMS could detect. These experiments, and many others, represent our best attempts to pierce the veil of mystery that surrounds dark matter. Each one is a testament to human ingenuity, our relentless pursuit of knowledge, and our desire to understand the universe we live in. Despite these efforts, dark matter remains elusive, refusing to reveal its secrets. In the face of this elusive phantom, scientists have developed various theories to explain dark matter's nature. The mystery is profound, and the theories are as varied as the minds that conceive them. One of the leading theories in this enigmatic field is the WIMP theory. WIMP stands for Weakly Interacting Massive Particles. As the name suggests, these particles are thought to interact only weakly with other particles, making them incredibly difficult to detect. They are massive in the sense that they have mass but are elusive, slipping through our detection equipment like phantoms. If WIMPs exist, they could account for a large portion of the universe's missing mass, solving the dark matter mystery. On the other end of the spectrum, we have the MACHO theory. MACHO stands for Massive Astrophysical Compact Halo Objects. Unlike WIMPs, MACHOs are not new types of particles. Instead, they are ordinary matter, just in forms that are hard to detect. They could be brown dwarfs, neutron stars, or black holes. Objects that emit little to no light but have substantial mass. If a significant number of these MACHOs exist in the universe's halo, they could explain the gravitational anomalies attributed to dark matter. Of course, these are not the only theories. Some scientists propose that dark matter doesn't exist at all, and what we perceive as its effects are simply due to our incomplete understanding of gravity. Others suggest that dark matter might be composed of particles we haven't yet imagined. The debates and research in this field are ongoing, with brilliant minds around the globe striving to solve this cosmic riddle. Every new discovery, every innovative theory brings us a step closer to understanding the nature of dark matter. And so, the quest continues, with the secrets of dark matter still waiting to be unlocked. From the early observations of Zwicky to today's cutting-edge research, the journey to understand dark matter has been a thrilling one. We've journeyed from the first inklings of its existence, through the perplexing discovery of an invisible mass influencing the cosmos, to the ongoing experiments that seek to unveil its secrets. We've explored the depths of space from our laboratories on Earth, using advanced technology to study the distant galaxies where dark matter's presence is felt. We've delved into the theories that attempt to explain this enigma, from the exotic WIMPs and axions to the concept of modified gravity. Each theory, each experiment, brings us a step closer to understanding, yet the enigma persists. Dark matter, unseen and yet so influential, remains one of the great mysteries of our universe. As we delve deeper into the cosmos, the mystery of dark matter continues to captivate us, a testament to the unending curiosity of the human spirit.